I'm Darren Meyer, Staff Research Engineer with Endor Labs, and I want to show you today how you can use Endor Labs to add a container vulnerability scan to an existing source code scan project. I've picked as my example the matrix.org Synapse server. This is a federated chat platform. This is the server component of it. It's a Python and Rust application that also produces a Docker image that's tagged with each release version. So I have a couple different versions in my local database here that I've scanned. I'm going to focus on 1950 for today's example. And as you can see, I've already added in the two components that I have. I have a Rust component and I have a Python component. I have findings for those and all the normal things you would expect from us as an advanced SCA product. Information about function reachability, remediations, all of that. So what I want to do now is I want to be able to find out for the container scan, what do I have for vulnerabilities in the container? And since container scans are also going to show me application vulnerabilities in the dependencies, I want to be able to find out, did they come in through the container or did they come in through the software project itself? So I have a checked out copy of the software project here. And the first thing I'm going to do is I'm going to check out the tag so that I'm scanning the same version of the source code that produced the container image. Then I'm going to ask our Endor CTL, which I can run on my desktop here or in CI. And what I'm going to do is I'm going to ask for a scan, and it's a container type scan. And I'm going to give it the path to the public image. So this is the Synapse server tagged to that same version of 1.95.0, right? And I'm going to let it know that I want to correlate with the project, the software project that's in the current path. So this is the checked out version of Synapse server that's locally on my machine. And I'm going to let that run. Now this doesn't take very long. It takes 15, 20 seconds, depending on your internet connection. And it's going to enumerate all the vulnerabilities in the container and all of its various layers. And then I'm going to show you how that correlates with this source code project. So we're almost done here. It took about 20 seconds. So you can see it discovered the one container that we asked for, and there's a handful of findings associated with it. And if I reload this page here, you'll see that I now have also the matrix.org Synapse Docker image added to this project. So now I have all of the components in one place. And if I look at just that component, you can see I have 63 findings that it found. Some of these are vulnerabilities. There are other kinds of operational risks, things like that. And I can actually look at what is happening in each layer here. So I can look at each layer of the Docker image in this case and look at where various things were introduced. In this case, I can see curl has a number of findings associated with it. And in this particular version, libxml2 has a number of findings and so on. So I find out that if I want to have these patched, this layer is ideally where I'd like to patch, or I can add over the top of it. But I have to add after this layer, or I'm going to end up getting my installations back, right? I'm going to end up with my vulnerabilities back. So I have a lot of information about how and where to fix things that show up in the container specifically. But of course, some of these things are Python vulnerabilities. You see this vulnerability in setup tools, for example, is part of the Docker image. Now, which of these are things that are an issue with the image, and which of these are the issues with my application? And to do that, I need to go back to the project view and look at the overall findings for the project. I can see that entire pile here and see how they're showing up next to each other. And when I group those by finding and dependency together, things start to stand out. Here you can see I have, with this CVE, there's just one finding. It's Debian correlated, right? There's one package. However, with something like Python cryptography package here, you can see that this particular vulnerability is in my container, but also is in my application, which is pretty strong evidence that my application is why it's there. Of course, I also have information that the vulnerable function's unreachable, so maybe not the highest priority thing for me right now, as opposed to this one in setup tools where I can see, again, this came in the container and in the Python package, and it's a reachable function, so I want to start fixing this one. So this really helps me prioritize and figure out what to do in response to fixing vulnerabilities that exist in the deployable container, and find out, did they come from the container and its layers itself, or did they come from my application? I hope that was helpful.